Hello class, I'm working out of your geometry book 3.1, Transversals with Parallel Lines. We're going to look at the angles a transversal creates. So in a transversal, we have two parallel lines, and the transversal is the line that intersects both parallel lines. We can label the angles this creates as 1, 2, 3, 4, 5, 6, 7, 8. If we have information for even one of these angles, we have a lot of information for the transversal. So let's look at all the parts. First of all, we have an interior to the parallel lines. This would be the inside. And there is an exterior to the parallel lines, the outside. Think about that. So in the labels of the types of angles that are created, it has to do with whether the angles are interior or exterior to the parallel lines. Let's look. So we see 3 and 5 are inside the parallel lines. These are called same side interior angles because both of those angles are on the line and they are on the same side of the transversal. Same side interior angles. That is the set of angles that create a line which would be set equal to 180 degrees if added together. 4 and 6 are same side interior angles as well. All right. Alternate interior angles. So alternating on either side of the transversal, we have 3 and 6 and 4 and 5. These angles to one another are congruent if the lines the transversal cuts through is parallel. So we have 4 and 5 are the same degree in angle, and so is 3 and 6. Let's look at the exterior angles. One and 8 are alternate exterior angles. They're both exterior to the parallel lines, and they're on alternate sides of the transversal line cutting through the middle. They are congruent. So if you have the degree for angle 8, then you also have the degree for angle 1. The other set of alternate exterior angles are 2 and 7. If you have the degrees for angle 7, then you have the degrees for angle 2. And let's look at corresponding angles. These are a little different in definition. They have the same relative position on each line on the same side of the transversal. That would be 1 and 5, 3 and 7, 2 and 6, and 4 and 8. So 1 is congruent to 5, 3 is congruent to 7, 2 is congruent to 6, and 4 is congruent to 8. We have sets of vertical angles also. If we know 7 in degrees, then we also know 6 in degrees, for instance. So is it with 5 and 8, 2 and 3, 1 and 4. So there are lots of parts of transversals to practice. But if we think about the definition and we think about what we know about vertical angles, and we think about a line creates 180 degrees when added together, we can apply all the names and definitions well after practicing. Going to work number 20 in your book. You're given the measure of angle 2 and the measure of angle 3. The measure of angle 2 is 2x plus 8 degrees. The measure of angle 3 is 6x plus 4 in degrees. You're asked to find the measure of angle 2 and 3. First, we have to solve for x. To do that, we're going to look at our diagram and see that the measures of these two angles create a line when added together, and that's how we'll solve for x. So we'll have 2x plus 8 parentheses set plus 6x plus 4 parentheses set equal to 180. Combine like terms. 2x plus 6x is 8x. 8 plus 4 is 12 equals 180. Subtract 12 from both sides. 8x equals, as this goes away, 168. Now we can solve for x by dividing by 8 on both sides. This goes away. We'll have x equals 21 degrees. Now we substitute in everywhere we see x in measure of angle 2 and measure of angle 3, 21 degrees. So for 20b in section 3.1, we have the measure of angle 2 is equal to 2x plus 8 again. So we'll say 2 times 21 plus 8. Yep, 42 plus 8. And the measure of angle 2 is 50 degrees. 20c will solve for the measure of angle 3, which equals 6x plus 4. So 6 times 21, 4x plus 4. That is 126 plus 4. And that is equal to 130 degrees for the measure of angle 3. I hope this helps, and I will see you soon.